presentation of mathematics. In the quality improvement in maths education project, I am representing this video based PPT presentation 2019. The topic of presentation is of subject geometry and topic is similarity. The name of master trainer, myself, Mulla Nisari Ahmad Muhiddin, MTE150. My school name is Nyamurthy Ranade Vidyalay, Kapshi Senapati, which is in Kolhapur district of Maharashtra. For this PowerPoint presentation, my guides are Professor I.K. Rana of IIT Bombay and Professor H.G. Gharapure of IIT Bombay. So, RMSA MSCRT Maharashtra and IIT Bombay, they take our training mathematics workshop at Lonavala. Myself again, Nisar Ahmad M. Mulla of Naimarthi Ranade Vidyalay, Kapshi Senapati, District Kolhapur. My registration number is MTE 150. So, in the subject geometry, I am taking the topic similarity, where subtopic is geometric mean. So, first of all, we observe and explore. So, look towards these slides. In first, here are similar objects. This, and this. We know here are also these objects are smaller, medium, large. Look towards these two stars, these two pictures. When objects are the exact same shape, but they are different sizes, then we say that they are similar objects or figures. We already learned this. In Photoshop, when we do or large some figures in this way, when we double the length and width of photo, we enlarge it using scale factor of 2. In nature, there are also similar triangles. This is the tourmaline crystal cross sections containing similar triangles. This one is one triangle, another this triangle. In craft also similar triangles can be used to great effect in art and craft as seen in this colorful and creative patchwork quilt. Determining similar objects. So in our last figure, we see that when we want to make large type of picture, when we compare the ratios of the matching sides, this and this, suppose this is 4, this matching size is 8, this size is 3, and image size is 6. So similar means exact same shape, but different are size. For photo enlargement, we know that similar factor new upon old, this is 16 upon 4. When the ratios are not in the same ratio, then they are not are in the similar. We also learn that when two triangles are similar, then that triangles are also are in the exact same shapes but are in different sizes. Here look here, triangle ABC and triangle DEF. DE is of 5th centimeter and AB is 10 centimeter, hence double size. Here EF is 8 and BC is 16 centimeter. So this is also of double. EF FD is 6 centimeter and AC is equal to 12 centimeter. Here also side is double. Look here towards the measurements of angle. Angle A is of 65 degree, angle D is of 65 degree, angle C is of 40 degree, angle F is of 40 degree, angle B is of 75 degree, angle E is of 75 degree. So the angles are same and sides are in proportional. Hence, these two triangles are similar. This is the sign is of similar. We also know AA test, SAS test, SAS test of similarity triangles. Now we are going to understand mean proportional. In algebra, we know that the mean proportional of A and B is the value of x here. A upon x is equal to x upon b. So A is to x and as x is to b. It looks kind of hard to solve, doesn't it? But when we cross multiply, then A b upon x is equal to x. So x into x square, x square is equal to ab. Hence, we can find x is equal to square root of b. Now look here in right angle triangles. This is one triangle. Suppose this is the base and we draw altitude in this way. This is the now altitude. Take a right angle triangle sitting on the hypotenuse. This is triangle is on hypotenuse and we can draw this altitude from upper vertex. So this is main triangle. This form the second triangle and this form the third triangle. So this triangle is yellow color. This someone blue and this is dark blue. So all these are similar. So you can try this activity, cut a right angle triangle from a piece of paper, then cut it through alternate, see if the pieces are really similar or not. So in this PowerPoint presentation, we can define and prove the geometric mean. Look here, geometric mean of a similar triangle. The altitude to the hypotenuse, this is BD is the hypotenuse of a right angle triangle, forms two triangles that are similar to each other and to the original triangle also. So look here, triangle ABC, this big one is similar to triangle BDC, this one triangle, and also this triangle is also similar to ADB. Now look here, here B is 90 degree, in this triangle D is 90 degree, and in ADB this one is also 90 degree. In ABC and BDC, angle C is common. So these two triangles are by similar by AA test. This also in this triangle also ABC and ADB, angle A and angle A is similar. Here angle B is of 90 degree, here D is 90 degree. So these two triangles are similar by AA test. Also this all three triangles are similar to each another. Okay. Now look towards this diagram. We have these triangles. This main triangle ABC. Here is pink colored BDC, and this one is ABD. So look here, D is 90 degree. Here D is 90 degree and B is 90 degree. So we can say that these three triangles are similar to each another. Now we are going to learn define altitude rule. We know that this is altitude, this is of left side and this is of right side. So left upon altitude is equal to altitude upon right. Use this rule, left upon altitude, altitude upon right. By using, now we can find the height h of this altitude, 4.9 upon h upon 10, h into h square, 4.9 into 10. So this will get 49. So taking square root of both sides, h is equal to root 49, which is equal to 7. Leg rule. This is the leg, this is the hypotenuse part, big part, and this hypotenuse small parts, this is the leg. So again remember, hypotenuse upon leg is equal to leg upon part. In this figure also, hypotenuse upon leg, leg upon part, but this is the leg and this upon part. We can use this rule for solving the examples. So in this diagram, we know that 6 upon x is equal to x upon 3. Here x is the geometric mean of this right angle triangle because this is the altitude. X into x, x square is equal to 18. Take square root of both sides. So root 18 is equal to root 9 into root 2. So taking square root, we get 3 upon root 2. In this figure, we can find this hypotenuse 7 upon y and y upon 2. So y square is equal to 14. Y into y square, 7 into 2, 14. So take square root, y is equal to root 14. So we can do evaluation. In this specific diagram, what is the value of x? As we know, we already learned hypotenuse upon leg and leg upon part. So take all hypotenuse, BD plus DC is equal to 9 plus 7 is equal to 16. So thus we get 16 upon x, x into 9, x into x square, 16 into 9, 144. Take square root of both sides, x is equal to root 144. So taking square root of 144, we get 12. So we are going to solve another example. Here is Sam loves kites. So look towards this kite diagram. P, Q, R, S. Is this a kite? It has two struts, PR and this QS, that intersect at a right angle at O. We know this is property of kite. The hypotenuse intersects each other. Big hypotenuse makes some equal parts which is perpendicular bisector of small hypotenuse. So look here, PO is equal to 80 and OR is equal to 180 centimeter. The fabric of kite has right angles at Q and S. Now Sam wants to know the length for the strut QS. Okay, and also length of each side. We only need to look at the half kite to the calculation. Here is the left half rotated QRP. Now look here, h square is equal to 80 into 180. The product is 14400. So h is equal to square root of this 14,400. Hence we get h is equal to 120. So 120 into 2 is equal to 240, which is the length of QS. Now length of RP is equal to RO plus OP. 180 plus 80 centimeter is equal to 260 centimeter. Now use the leg rule to find R. R square is equal to 260 into 80, which is equal to 20,800. Hence, taking square root, R is equal to 144 centimeter to nearest centimeter. Use the leg rule to again find the value of P. P square is equal to 260 into 180. Hence, we can get 46,800. Taking square roots, P is equal to 216 centimeter to nearest. Tell Sam that the stress QS will be 240 centimeter and the slides will be 144 and 216 centimeter. Now look towards this diagram in triangle ABC. Here the altitude is given 5 centimeter, CD is equal to 4 centimeter. Find the value of BD. So here are four choices for answer A, B, C, D. We know that altitude square AD square is equal to BD into CD. Hence, 5 square is equal to X into 4. So 25 upon 4, which is 6.25. So C is our right answer. The geometric mean we can use for finding the height of roof. Here is XYZ in is a right angle triangle. If we calculate, if we want to know YW, which is the height, so take this distance 5.5 meter, this distance 3.1 meter, and this distance between two wall XZ is equal to 6.3 meter. So identify the similar angles and find the height h of the roof. We know very well that by using the geometric mean rule, these two triangles are similar to main this right angle triangle. You may find it helpful to sketch the three similar triangles so that the corresponding angles and sides have the same orientation. Mark the congruent angles. Notice that some sides appear in more than one triangle. For instance, XY is the hypotenuse in XYW and the shorter leg is XZY. So these three triangles are similar. XYW similar to triangle YZW, similar to triangle XZY. So here we can find the height. Thus, we can solve by using geometric mean formula the altitude in any right angle triangle. I am going to thanks for IIT Bombay team and special thanks for Rana sir who guide us also Mahesh Verma sir and other technical team. Again, I am going to thanks for IIT Pavai, also RMSA, Maharashtra Sarkar Shasan because they choose us for training purposes and we take this training, and by taking this training we can use this observe and explore, define, prove and evaluate theme in our regular learning teaching method so that the students can understand very easily. Again, I am going to thank you.